Hello everyone and welcome to our first day of notes for 2022. So today we're going to be learning about a concept called the law of sines. So you'll recall last semester we did do sine, cosine, and tangent, and when we did those, we used sine, cosine, and tangent when we had right triangles. So today we're going to investigate and see what happens when you want to find a measure in a triangle, but it's not a right triangle. So the one shown below is not a right triangle. Because angle A is 33, angle C is 47, those two angles add up to 80, which triangle sum theorem then says angle B would have to be 100 degrees. So it's not a right triangle. Okay, so what we're going to do here is we're going to drop an altitude from angle B to the opposite side. So remember that means we are going to draw in this dashed line and we're going to create two different right triangles. We have the one on the left, and we have the one on the right. So if I focus on the one on the left here, the side that I'm missing, that I'm going to look for that is shared with the triangle on the right side, is the height, h. So now we're going to have to figure out which trig function to use. Here's my angle, h is the opposite, 14 is the hypotenuse, that means I'm going to do sine. So sine of 33 degrees is going to equal opposite leg, h over the hypotenuse 14. Put this over 1, cross multiply, we get h is equal to 14 times the sine of 33 degrees. Now, I'm not going to type that into my calculator because I'm going to have to use that right now to do the triangle that is on the right side. Right, so I know h, which I just found, is 14 times the sine of 33, so I'm just going to write that over here below h. And now we focus on this triangle and decide, okay, which trig function am I going to use? Here's my angle of 47. 14 times the sine of 33 is some decimal, I don't know what it is. That's the opposite sine. A would be the hypotenuse. So if I have opposite and I'm looking for hypotenuse, that again is going to be sine. So sine of 47 degrees equals opposite 14 times the sine of 33 over the hypotenuse, which is A. All right, we're going to put that over 1, and now we're going to cross multiply. Cross multiplying, I should get A times sine of 47 equals 14 times the sine of 33 times 1, which is just 14 times the sine of 33. My goal is to get A by itself, this little A right here, so I have to divide away sine of 47 degrees. And A is going to equal then, if I type this into my calculator, A will be approximately 14 sine of 33 divided by the sine of 47 degrees is 9.92. So that was quite a bit of work and a lot of steps to find this missing side of the triangle. So initially I was missing side A. I had to split this into two right triangles, use right triangle trig 2 times, and then finally get the side. Okay, so as it says here, we can, let me just zoom out. Okay, we could solve for the missing side by setting up two right triangle trig equations, like I just did up in the first example. But we can also derive a formula that'll let us find the missing side with just one equation. So we're not going to have to do this every single time. And that formula that we're going to derive is called the law of sines. So what I'm going to do is I'm going to do the same thing. I'm going to split this triangle right here. I'm going to split it by dropping down the altitude, and I will call that altitude h. So if I want to set this equation up, it's going to be sine of angle A equals the opposite, which I called h, over c. Cross multiplying, I would get h is equal to little c times the sine of angle A. I'm going to do the exact same thing for this triangle on the right side. Sine of angle C equals opposite h over hypotenuse A. Put this over 1. Let's solve for h. H is going to equal A times the sine of angle C. All right, so hopefully, or maybe you haven't, but now you will see that I have two different expressions here for what h is equal to. H in this triangle is going to equal c sine of a, or it also equals a times the sine of c. So because two h's equal each other, I set those two equal. So c times the sine of a is going to equal a times the sine of c. That is substitution, right? They both equal h, so therefore they equal each other. Now, I want these little constants gone. I want c, the little c in front, gone from the left side. I want little a gone from the right side. So what I'm going to do is divide both sides by ac, because by dividing by c, I cancel that c out, and dividing by a, I'll cancel the a out that was in front of sine of c. So now when I clean this up, I get sine of a over little a equals the sine of angle c over little c. Okay, so let's take our focus and shift it now to this triangle on the right. If you notice, these are exactly the same two triangles. They don't look different at all. They're labeled, the vertices are A, B, and C in the exact same order, but now this side and this side are labeled. So what I'm going to do is draw an altitude again, because remember, every single triangle has 3 altitudes, but this time I'm going to draw it from angle C to side AB. So this is going to be my altitude that I'm drawing in. Now I'm going to call that H as well, but I'm going to call it maybe like H sub 1, because I already used H over there, so just to show that it's two different heights. And now we're going to do the same thing. We're going to look at the two angles, the two acute angles here. So B, H1 is opposite. A would be the hypotenuse. So I would write sine of B equals the opposite leg, H sub 1, over the hypotenuse A. Let's solve for H sub 1. Let's put that over 1. We're going to get H1 equals A times the sine of B. Okay. Let's do the same thing, but now let's do it for angle A. It's going to be the sine of angle A equals, again, sine is opposite, so H1 over the hypotenuse in this case would be B. Put that over 1 and let's cross multiply. H1 is going to equal B times the sine of A. All right, so hopefully you notice, just like before, both of these H1s, which is the same segments, the height in that triangle is equal to two different things, A sine of B, B sine of A. If H1 is equal to both of those, then they have to equal each other, so A times the sine of B equals B times the sine of A. I would like to get rid of the little a and little b. Sorry, this should be a capital A. So I want to get rid of little a by dividing it from both sides, and little b by dividing it from both sides. And what happens here is my a's drop out, and over here my b's drop out. So what I'm left with is sine of b over little b equals the sine of angle A over little a. So from the first triangle, we had sine of A over A equals sine of C over C. Sine of B over little b equals sine of A over little a. So because these are both equal to sine of A over little a, they all three equal each other. So my extended ratio or proportion could be sine of A over A equals sine of angle B over little b equals sine of angle C over little c. And that's exactly what we have here on the top of this page. So we have developed the law of sines. We can use this formula to solve for parts of a triangle that are not right triangles if the given information applies to one of the three cases. You either have to have angle, side, angle, angle, side, or side, side, angle. So if you have angle, side, angle, and angle, side that are given to you, you're going to get one unique triangle. There's only one type of triangle that would be able to be formed. But if you have side, side, angle, it's called the ambiguous case, because you might not have any triangles, meaning 0. There could be one triangle that could be formed, or two triangles, depending on the measurements. We don't have to worry about that too much in this class. You're going to learn that when you get to pre-calculus 2 years from now. So that's when you're going to talk about the ambiguous case of how it is possible for there to be no triangles, one triangle, or two potential triangles, because then you have to worry about, well, which one is it? Okay, so what we're going to do here is we're going to use the law of sines to find the missing side in this angle, angle, side case. Notice I have angle, angle, side. All right, so what I always do and what I look for to know that I'm going to use law of sines, because tomorrow you're going to learn a different law of cosines, is I always look for this relationship where you have an angle and its opposite side. So I have that right here with the 16 inches and the 47 degrees. So the law of sines says sine of the angle, 47 degrees, over the side across from it, so 16 in our case, is going to equal, now we have this situation, we're going to look for little a. It's going to be the sine of 33 degrees over little a. Okay, I'm going to cross multiply, so it's a times the sine of 47 degrees equals 16 times the sine of 33 degrees. To get a by itself, I would have to divide both sides by sine of 47. And then to get a, I will use my calculator. So in my calculator, I'm going to type in 16 sine of 33 divided by sine of 47. My answer is going to be approximately 11.92. Remember, if you're not getting that on your calculator, maybe your mode is wrong. Maybe you're in radians, so you're going to have to go and change that. So you press mode and make sure your highlighted unit is degrees, not radians. For the second example here, we're going to show that there's no solution for this given side-side angle case, because we have a side-side angle. So again, when you're starting off, you're not going to know that there's no solution. You're going to start it off thinking, okay, I have an angle and it's missing, or it's opposite, an angle and its opposite side. I have that, and I'm looking for now this situation. So it's going to be sine of 34 degrees over the side across from it, 2, equals sine of, I don't know the angle, it's a, over 4. I'm going to cross multiply, so I get 2 times the sine of a equals 4 times the sine of 34 degrees. I want to get a by itself, so I'm going to divide both sides by 2. I have sine of a equals, this 4 and this 2 can be reduced, so it's going to be 2 times the sine of 34 degrees. And now hopefully you recall, when you're looking for an angle, you have to use inverse trig. So a is going to equal the inverse sine of this entire thing, 2 times the sine of 34 degrees. On your calculator, do second sine, and then in parentheses, write 2 sine 34 degrees, close the parenthesis twice, and your calculator is going to tell you error. There's no such triangle that could potentially or possibly exist with these measurements. If you took a 2 centimeter stick and a 4 centimeter stick and then made a 34 degree angle, there's not, that triangle is not going to be, it doesn't exist. Okay, so here there would be no triangle, no solution. Okay, over here we're going to solve this triangle as well. So remember what solving a triangle means. That means you want to find every single missing piece that you don't have. So in this example, we are going to be looking for little b. We're going to look for the measure of angle A, what that is. Oops. And the measure of angle B, we're going to find what that is approximately equal to. All right, so in this example, I have side, side, and an angle. So some of you may be like, well, you're not supposed to be able to, that doesn't exist. There's no A double snakes, like I said, forwards or backwards. And you're right, there isn't. But remember, we're not trying to prove triangles congruent here. I'm just talking about what we're given, what pieces of information. If you're given side, side, and an angle, then you're going to use law of sines. Okay, but again, I always quickly just look and I think, okay, do I have an angle and its opposite side? I do. That means it's going to be a law of sines problem. So I'm going to write sine of 43.5 degrees over 10.7 is going to equal, now I have this piece of information because I have that side at 7.2. I would not use this relationship because I don't have angle B and I don't have side B. So I can't use that particular angle on its opposite side, I have to use the a's because I at least have one piece of information there. So I'm going to do sine of angle A over 7.2. If I did the b's, I would have two unknowns, angle B and side B, so I'd be stuck. I want to be able to solve that. Okay, let's cross multiply and solve for A. So I'm going to get 10.7 times the sine of angle A equals 7.2 times the sine of 43.5. First thing I'm going to do is divide by 10.7. So now sine of A is going to equal 7.2 sine of 43.5 over 10.7. And I'm not going to type that into my calculator yet because I don't want to keep rounding. So instead, I'm going to wait till I get to this step and then type everything in. So it's going to be inverse sine of 7.2 sine of 43.5 over 10.7. Please, please, please use your calculators. Make sure that you can do this on your own. Watching me do it doesn't mean you're going to be able to know how to type it into your calculator. And if you're doing this on a quiz or test, that's going to be too late. I can't help you then. So make sure you take your calculator and get comfortable using it and finding this information. We get A is equal to 27.59 degrees. All right, so I have at least this piece of information. It's 27.59. Okay, I do not, to find angle B, I don't have to do trig at all. I know the three angles of a triangle. If this is 27.59, then angle B is going to equal 180 minus the sum of these two. I would add 27.59 plus 43.5, and I would get my approximate answer of 108.9. Okay, so now that I know that that's 108.9, I have to do law of sines one more time to get side B. Oop. Okay, so let's do the same thing. We're going to do sine of 43.5 over 10.7, which was my initial angle and its opposite side, is going to equal, now because I'm looking for little b, I'm going to do sine of angle B, which we found is 108.9, divided by little b. Okay, it's just some algebra here, some cross multiplying, we're going to get little b. So little b is going to equal b times the sine of 43.5 equals 10.7 times the sine of 108.9. Divide both sides by the sine of 43.5, and then use your calculator to find what that is. So you're going to type in 10.7 sine of 108.9 divided by sine of 43.5. You should get B is approximately 14.71. And so then these are my three missing pieces. He asked me to solve the triangle. That's what I would get. All right, as far as this last example, we are not going to do it because this is actually going to come up in a couple of days. So for now, we're just not going to worry about number 4. Make sure you know how to type this in. Please come with any questions to class the next time I see you. All right, thank you so much for watching. Have a great day. Bye.